Okay, this is lesson 6-8 for the Ready, Set, Go problems. And this is 1. A banana divided by a banana is always 1. Cancel out the 1/5. You have 8√3. Okay. This is 16. How do we know it's 4? 8/1/2 can't be the same as 8/2, right? So it's not dividing by 2. Can't be 4. Cancel the common factor here of 1/2. This one, we rationalize the denominator, which I know you did in math too. Okay, make sure you're keeping track of that. 3/√3, multiply both sides by √3. And it does the same thing. The 3's cancel this time. All right, next, 4/√8. Let's see, √8 is pull out the biggest perfect square you can. So it's 2√2. Cancel the 2's. Multiply by √2 top and bottom. Yeah, that's all I want to say about that one. 2/3 over 1/2. We don't have a common factor. We'll have to just flip. Cancel the common factor of √7. There we go. Okay, these are equal, so this is also √2, which means the angles are 45-degree angles. Hypotenuse, Pythag, so the hypotenuse is 2. And if it's isosceles, these are both 45-degree angles. Okay, remember that so it's all consistent. All right, each point on a circle marks the end of a terminal ray. Yeah, okay. So what do we have here? We have odd multiplies of pi/4 are the ones in the middle of a quadrant. So 45 degrees, pi/4. So 2 pi/4 is pi/2. Pi/2 is a right angle. 4 pi/4 is just pi, which is halfway around. If we go backwards, we have negative pi over 4. Okay. Something to note. Can't write anymore. Okay, let's get all the points here. Over 0 up 1, the radius is 1. Unit circle. Okay, this point is negative 1, 0, and this is 0, negative 1. What's the points at 45 degrees? Oh yeah, root 2 over 2's. This is still up, but it's left and up. So negative root 2 over 2, but still positive root 2 over 2. This quadrant, both things are negative. Here we're going right, positively, but down. I'll just make a little note for this, right? For this. Okay, so notice that okay, arc length. Arc length is radius times radians. Okay, because of the 1, 0, we know the radius is 1. Okay, so for this angle, which is pi over 4, the arc length and then we'll just do the rest of them. I'm putting in times the radius. There's 8 angles. See the problem 11, top of the page. Okay, next. Sine of 5 pi over 4. So where is 5 pi over 4? Remember, 5 pi over 4 and 7 pi over 4 are down below 745 are down below, and the height is negative. Are below the x-axis. So negative root 2 over 2, but it did say to turn it into a decimal. You can check on your calculator by making sure your calculator is in radians. Okay, sine is opposite over hypotenuse. On the unit circle, now that we're going past 90 degrees, sine is the height on the unit circle. If you have something where the hypotenuse is not 1, you still have to divide by it. Okay, pi over 4. Where is pi over 4 and where's 7 pi over 4? Well, pi over 4 is easy. Where's 7 pi over 4 again? Here's pi over 4, 7 pi over 4. Oh, both of these are going right. So okay, that's easy enough. Sine of 3 pi over 4. Okay, where is that? Here's 3 pi over 4. Mink. Sine is height, and that's still positive. But cosine has gone negative because you're to the left. Okay. They aren't both positive unless you know you're in the first quadrant. All right, how do we do this? 2 cosine of 5. Okay, I'm going to make this longer because otherwise it's just annoying. Here's an easy way to do this. I'm going to mark off 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. This would normally be 2 pi, but okay, so instead of this being pi, it would be pi over 5. And instead of this being 2 pi, it'll be 2 pi over 5. We'll call that 72 degrees. I'm not going to be, yeah. Okay, for cosine, start out at its maximum height. We know the amplitude is 2. So it gets up to a height of 2, down to a height of -2. I always draw those in, and it starts out at its maximum height. Sorry, 2 pi over 5 and 4 pi over 5. What am I doing? I'm not going to do the whole thing, but we said do 2 periods. So 2 pi over 5 is 72 degrees. And that's for 1 period. Oops. Okay. This one we're going up to, and upside down. So I'm going to make it go from, let's see, what's the range? So -3 to 3, and then upside down is still -3 to 3, but then up 2. So up 2 is -1 to 5. So, and upside down. So let's mark in 8 periods. 8 bits, 3, 1 period, 2 periods. Okay, so it starts at the bottom. The middle is not the x-axis anymore, so I need to draw in guidelines for the middle also. All right. Period is 2 pi over 9, which is 40 degrees, incidentally. Okay, let's see. -5 to 5, down 3, becomes, let's see, -8 and 2. And then the center down 3 is -3. So let's just draw some things. Let's call this -8, since we don't have a whole lot of space. And 2. And halfway down is -3. Okay. And upside down. Let's see, 1, 2, 3, 6, 7. I can't be bothered to make it too much longer. Am I mumbling? Yes, I am. Okay. Whee. Oh, golly, Ned. This one's... Well, they gave you plenty of room. So I'm just going to... Or at least they gave me plenty of room. Haven't checked with the actual student edition. But let's just... I'm going to draw it here. Okay. So -15 to 15 and then up 6 is actually going to be -9 to 21. And the center is up 6, so the center is at 6. -9, 21, center at 6. This one is sine. Yeah, this one is sine, which starts out in the middle. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Up, middle, down, middle, up, middle, down, middle. And we've got 2 waves of the sine wave. Good enough. Okay. Something to notice. So we've been looking at non-horizontally shifted things, but if we start allowing shifts, a lot of different weird things can happen.